Welcome back to another Algebra 2 video. In this one, I'm going to teach you how to graph things that aren't straight lines. So far, every video I've done for this course has been drawing straight lines, whether it's slope y-intercept form or point slope form. But in this one, we're going to explore some other shapes. Now, before we get started, I want to kind of give you an idea of what we're going to be doing. I'm going to be graphing 5 new shapes. And the point of this video is just to understand why the numbers create the shapes that they do. And eventually you're going to memorize what these shapes are, because in the future, actually in the next video, we're going to use those shapes to move them around and do more interesting things with them. But these are not random. There's going to be 5 of them, and I want you to take meticulous notes, have some graph paper with you as you're watching this, and draw these the way I draw them, and draw them with the dots exactly where I put them. And you're going to memorize these shapes and use them a whole lot over the next couple of weeks in this course. Okay, so the first one we're going to do is going to have an x squared. Now, nothing we've done so far has had an exponent in it when we've graphed them. So we're going to start exploring what happens when we do have exponents. Now, the name of an equation that has a square in it, as long as there's not one larger than that, like a power of 3 or power of 4, is called a quadratic. So I'm going to go ahead and name this. This is a quadratic equation, or a quadratic function. Now let's see what this shape is going to be when we graph it. Let's just assume I don't know how this thing's going to look. I don't know anything about it. I'm just going in blind. Well, what I could do is just start plugging some numbers in to find out what the answers are, and that's going to give me the points that go on this graph over here, right? So let's make us a chart. Here's my x and my y. Now, you don't have to do this every time. I want to be very clear here. You don't have to make a chart every time you graph one of these. But if you don't know what it looks like to begin with, and you have nothing to go with, and you're just completely fresh to this type of equation, then you can always plug things in to find out what it looks like that way. All right, but later we'll have some shortcuts. All right, let's remember, we're going to plug in numbers that are going to be relevant to our graph over here. So let's plug in numbers around 0. Let's say -2, -1, 0, 1, and 2. All right, let's plug in 0. So I'm putting 0 where x is. So that means 0 squared. Well, 0 squared is 0. That means when I plug in 0, when I plug in the x of 0, the y I get out is going to be 0. So left and right 0, up and down 0. Where is that? Right there, at the origin. And that's what's in my chart, and that's what's on my graph. Let's plug in the next number. Let's plug in 1. And some of you might be wondering, why did I skip halfway down the chart? I'll show you in a minute. It doesn't matter where you start in the chart. I just realized that might have confused some people. Don't worry about it. We're going to go back and catch those in a second. Let's do 1. So if I do 1 squared, in other words, x is 1, then y is going to be, well, 1 times 1 is 1. So that's going to be 1. So if I go over to 1 on my x, then my y is going to also be 1. That's what that means. All right, let's keep going. Let's do, I'm filling my chart. Plug in 2. That's here. 2 squared is, 2 times 2 is 4. And that goes on my chart. So the point 24 is going to be on my chart. Now, real quick, if this were a straight line, you would expect it to be here, right? 2, 2. But it's not. It's actually 2, 4. So I go up 4. That's that point right there. I'll even label it for you. That's the coordinate 2, 4. Because when I plug 2 in, I get 4. Let's go back and finish the chart from the other side. Let's plug in some negative numbers. What is -1 squared? In other words, -1 times -1. Well, a negative times a negative is a positive, so that's going to give me +1. So if I go to -1, the location of -1, my height, or my y value, is going to be a +1, which means it's going to be up here, which is kind of odd. If you're used to only drawing lines, this is already probably looking kind of strange. All right, now let me go ahead and put that in my chart. What about -2? Let's plug negative 2 in. Negative 2 times negative 2 is, well, it's the same thing. I'm still squaring just like I did on the other side down here. It's still 4. And because it's negative times negative, it's still positive 4. So if I go left 2 to this negative 2 position, the height is going to be also positive 4, which is up here. So if you notice, this chart is symmetrical, right? No matter what you plug in, whether it's a positive or negative, they're going to give you the same number, right? If you're going around 0 like that. So it ends up looking like this symmetrical curve-looking shape. And all these numbers between come from plugging in decimals. If I wanted to plug in decimals or numbers between 0 and 1 or 1 and 2, it would create all these little dots along this curve, and it creates this shape. And this shape has a name. Not all of the things that we're gonna graph today have a name. The equations will have names up here, but the shapes won't always. But this one is very, very special. This is called a parabola. You need to remember that. I'm going to underline the A because it's not parabola. We emphasize the I. So parabola, not parabola. And that is the name of this U-looking shape. So the quadratic is the equation itself, right? This is the quadratic, and it creates the shape that is a parabola. And if you see the parabola, you know that a quadratic equation created it. That's kind of how that relationship goes. All right, so in your notes, you should hopefully have the picture drawn with the dots exactly where they're supposed to go. And you're going to memorize the configuration of these dots, where they are in relation to each other, and things like that. Now, again, do you have to plug in the numbers all the time and do all this math? No. That's because you're going to memorize where these dots are. Okay, let's do another shape. That'll become more clear later as we do more of these things. The next one we're going to do is x cubed. This is called a cubic equation or a cubic function, or just cubic for short. So let's just jump right in here and start cubing some things. Let's use the same numbers we did last time. Negative 2, negative 1, 0, 1, and 2. Now, if you want to go ahead and fill out the chart yourself and then graph these points, you can go ahead and see what this thing's going to look like. It's a good exercise. If you'd like to do that, pause it, try it on your own, and go ahead and graph this. So even if you don't know how it looks, you can know how it looks, at least get a general idea just by plugging things in, just like I did. All right, let's start from 0 again. So I plug in 0. 0 cubed is 0. 0 times 0 times 0 is 0. What about 1? If I do 1 cubed, 1 times 1 times 1 is 1. That goes there. 2 cubed. 2 times 2 times 2? 8. I'm going to go ahead and just fill out this chart. We'll do it that way so you can see what it looks like to fill out the whole chart and then graph them. What if I plug in some negative numbers? Let me get rid of these. If I plug in negative 1, by the way, if I'm going too fast, you can always pause it and take a second to write things down. Okay, negative 1 cubed is negative 1 times negative 1 times negative 1 is negative 1. So that goes there. And the last number is negative 2 cubed. Negative 2 times negative 2 times negative 2. Well, that's 3 negatives. It's going to be a negative 8. And so that goes up here. All right, let's see what these points look like. All right, so I've got 0, 0. Let me change color just because. 0, 0 is here. This is 1, 1. So that's x value of 1, y value of 1. So far, it's the same as before. Now I have 2, 8. That means if x is 2, y is 8. So I go over 2 and go up 8. I think 8's that far up. 3, 4, 5, 6, 7. Yeah, that's right. So it looks kind of like our quadratic so far. But remember, our quadratic jumped back up because all the numbers were positive. It kind of went up that way, right? But this one's not going to, because look at negative 1. That's also going to be negative 1. So that means the next one here is going to look like that. Then, negative 2, negative 8. If I go left 2, I'm going to go down 8. And that gives me a point way down here. So it turns out that when you do a cubic, it's going to look kind of like a quadratic, but that left side is going to swoop down like that. Let me actually draw it. So it curves up like this. I like to do it in two pieces so I don't get the curvature wrong. So it curves up to that, and then it's going to curve like this, and then go up to that point. That's what the cubic looks like. Now, we should take a second and note something. You're not always going to have enough room to graph all the dots that I'm graphing. So the important parts of the cubic are the center, and then this one and this one. Those three dots. Now, if you're colorblind, I apologize because I just drew over that in green and it's already red. But the point is, I'll just draw arrows. These three dots are the most important ones. So as you're drawing cubics, those are the ones you should focus on. If you can't draw the points up here, that's okay. That's a long way up there, and they won't always fit. And that's totally fine. As long as you get the 3 points in the middle and you get the general shape, would be okay. All right. What if you did other things besides exponents? What if we had like a square root? Let me go ahead and write that. Square root function. That's going to look like y equals the square root of x. Well, you know how this goes. Let's just go ahead and start doing this. I'm going to plug in some numbers. Before I do, though, think about the things that I can take the square root of. I could take the square root of 1. Think about, I'm going to be plugging numbers into this. I can take the square root of 1. I could take the square root of 2, but it's going to give me a decimal, so I don't want to use that. So let me use, I could take the square root of 0, take the square root of 1. I could take the square root of 4, so let me plug that in. And I want to find out what's going on the left side, so let me go ahead and write down some other numbers. All right, let's plug these in. Square root of 0 is 0. So that means my first point is right here in the middle. And that's that there. Square root of 1. Well, if I plug in 1, square root of 1, 1 times 1 is 1. That's why the square root of 1 is 1. So that gives me this. So far, it's just like the other ones. Square root of 4. That's going to give me, well, 2, because 2 times 2 is 4. So that means if I go over 4, if I go over to the x value of 4, my y value is going to be 2. All right? Now let's look at what happens when I plug negative numbers in. Let's get rid of all this stuff. So the square root of negative 1. In other words, I'm asking what times itself gives me negative 1. Now, if you never really thought about that before, I highly suggest pausing this and coming up with a number. And then test it. Multiply it times itself and see if you get negative 1. Now, if you've tried it and you're confused, that makes sense because there's something really strange going on here. If you take, what's 1 times 1? Well, that's 1. What's negative 1 squared, or negative 1 times itself? That's also 1. The only way to make something times something else give you negative 1 is 1 times negative 1. But that's not going to work because you need the two numbers to be the same if you're doing the square root. That's the whole idea. What times itself? The same number. So is there a number that you can multiply times itself to give you negative 1? No, there's not. So there is no answer when I plug in negative 1. Same thing with negative 4 or any negative number. No negative number when I plug into this is going to give me anything. Now, later on, you're going to find out a way around this. And obviously, we're not going to talk about that right now. So if you're watching this after you've seen some of that stuff before, after you've seen that, yes, I am aware of those things, but we're not getting into complex imaginary numbers, things like that. So in the real numbers on this real number plane, for the purposes of graphing the square root function, those numbers do not exist. So that means that I'm going to stop right here at 0, and my function is going to look like this. It's going to curve up like that. Let me draw that a little better so I can go right through that dot. There we go, that's better. And notice my arrow is it's going to the right, but it's also still slightly going up. So it's going to continue to go to the right, and it's going to continue to go up forever. Very slowly, but it is going to continue to go up and up forever and ever and ever. And that's my square root function. All right, if possible, when we're graphing these things, I would like for you to use all three dots. So this one, and this one, if possible. Okay, let's do the next one. The next one's going to be kind of like that. We're going to call it the cube root function. Let me write that down, cube root. Now, sometimes when we introduce this in class, this might be at a point where you've never seen a cube root before. So at this point, you might be confused. You may have seen this before, and that's great. But many of you may not have ever seen what a cube root actually is. So let's actually talk about that for a second. I want to take a side note. If you already know all about what a cube root is, you can fast forward again or you can skip this part or watch it again, but until you see the graphs again. But I'm going to go over this blank page, and let's talk about what a cube root is. Well, a square root, first of all, is asking the question, what times itself gives you a number? So if I said 3 squared, that gives me 9. So that means that the square root of 9 is going to be 3. It's the opposite of that. It's asking what times itself gives you 9. That's what it's a question. The square root function is a question. It says what times itself gives you 9. And the answer is 3. That's what that does. All right, same thing with 4. What's the square root of 16? Or sorry, I gave the answer away. What's the square root of 16? Well, 4 times 4 is 16, so the answer is 4. Why? Because 4 squared is 16. Well, there are other exponents besides 2's. You can use 3's. I can cube things, right? I could say, okay, what's 2 cubed? It's 8. That's 2 times 2 times 2. That means you can undo that just as easily. So the cube root of 8 is like asking, what times itself 3 times gives me 8? What is the answer? 2. So you can think of a cube root as undoing cubes, just like a square root undoes squares. If I did another one, let's say 1 cubed. Well, 1 cubed is 1, so the cube root of 1 is 1. What else? I could do 3. 3 cubed. 3 times 3 times 3 is 27. Therefore, the cube root of 27 is 3. So that's kind of how that works. I should say not kind of, it's exactly how that works. That's what the cube root function is. And there's not really a way to make that simpler. Okay, not that I'm aware of. All right, so let's go ahead and plot some of these things. Actually, we can use the ones we already did. If I plug in, what did I plug in? I plugged in 1. The cube root of 1 was 1. Make my chart. I plugged in, what else did I plug in? I plugged in 8. The cube root of 8 was 2. Let's go ahead and plot those. That's 1, 1, and 8, 2. That's up here. But I didn't plug in any negative numbers, did I? Let's plug in, you don't have to put this in order. Let's plug in negative 1. What's the cube root of negative 1? In other words, what times itself 3 times gives you negative 1? Well, that's not a 1. Negative 1 cubed gives me negative 1, so that's the answer. The cube root of negative 1 is negative 1. So that's going to go down here. Oh, we skipped 0. What's the cube root of 0? 0. And what's the cube root of negative 8? In other words, what times itself 3 times gives you negative 8? Well, if you think about it for a second, you'll realize that negative 2 cubed gives you negative 8. Therefore, it's negative 2. All right, let me get rid of some of this over here so I can plot that without it looking bad. There it is. So what's that actually going to look like when I draw it? Well, it's going to give you this thing similar to a cubic, but it's going to curve sideways instead. And that's the cube root function. And just like our cubic function, these outside points are going to be difficult to draw and everything because they're so far out. But as long as you have these 3 points here and you have the shape correct, then that would be good enough for me. I'm fine with that. Now, just to kind of illustrate it on the same graph, the points are the same, the exact same points as the cube. So if I were to try to draw a cubic, it would look like, I don't know why I did it that way. There we go. Look like that. So that blue one is the cubic, and the yellowish one is the cube root. So they share the same three dots. It's just a matter of how you draw them. Right? Okay, we have one more graph to do. And here it is. Y equals the absolute value of x. This one's going to go pretty quick, but I like this one. I think it's really interesting. Okay, let's plug some numbers in and make that look a little better. There aren't any restrictions on what I can plug into this, so I'm going to go ahead and use -2, -1, 0, 1, and 2. If I plug in 0, the absolute value of 0 is 0. It's easy. What's the absolute value of 1? In other words, if you make 1 positive, what do you get? 1. That's easy. You should see a pattern here in a second. Absolute value of 2 is 2. What's the absolute value of 3? 3, 4. So as you do that, whatever number you put in is going to be the number you come out with. So whatever the distance to the side is going to be the same distance up. And when you do something like that, you get this nice 45-degree angle thing, where the distance here is the same distance here, right? Whatever number you put into the equation is going to be the number that comes out of the equation. That's why it looks like that. Kind of cool if you think about it that way. But what happens when you plug in negative numbers? Let's do that. Well, -1, absolute value of -1, is going to be a positive 1. So if I go left 1 in this region, I'm still going to get a number up here. Same thing with -2. If I plug in -2, I'm also going to get a positive number, and it is +2. So that's going to be up here. And if you keep going, you're going to notice that it's the same thing as on the right, but it's now up here as well. You can think about it, if you didn't have the absolute value, that line would have continued down this way, right? But this absolute value takes, let me draw that a little better. I think this is a really neat way to think about this. If you were to take the straight line, y equals x, and put absolute values on it, it just takes the negative side of it and it flips it up. And so you get this kind of broken looking thing that turns into a V. Kind of cool way to think about it. All right, so when you draw the absolute value, you don't have to draw all those dots. For me, for my students, I just say, as long as you get the original dot here, and then if you give me these two, and then you just kind of draw a diagonal line, it's going to be a perfect 45-degree angle, which means it's going to hit all these corners. And that should be sufficient. You don't have to draw all the single dots all the way. Okay, I think that's going to do it. I think that's all 5 of our graphs. And again, you don't be afraid if this was a lot. I'm not asking you to plug all these numbers and do all this math and stuff every time. That's not the point of this. Again, the point of this was to see what these shapes look like and to memorize what the shapes look like. So if you see a square root, it looks like this hook-looking thing. If you see a cubic with a cube in it, it's going to look like an S-looking thing. If you know its absolute value is going to look like a V. If it's got a square, quadratic, it's going to look like a U. So the point of this is to recognize the shapes and know where those dots go. But you don't have to do all the numbers and plug them in all the time, because I just want you to know where those dots are and memorize their configuration. A lot of that's going to make a lot more sense in the next video, where I show you how to take these shapes and move them around and modify them in different ways. All right? So thanks for sticking with me to the end. I hope this was something you understood and you got a lot out of it. And I'll see you guys in the next video.